Hi, everyone, and welcome to Supermicro's webinar channel. Thank you for joining us today in the webinar, High Performance Object Storage in 30 Minutes with Supermicro and MinIO. Joining me today is Siva, Solution Engineering at Supermicro, Echo, Engineer at MinIO, Matt, Technical Marketing at MinIO, and Bala, Senior System Engineer at Supermicro. And today they will discuss why the Supermicro CloudDC is the perfect combination of performance, reliability, craftsmanship, and flexibility for deploying MinIO object storage. Before we begin, I would like to highlight some key aspects of this channel and tools for you to explore while you watch. In the Downloads tab, you will find materials and web links to find documents related to our content today. And you will find a questions tab in which you can ask questions at any point throughout this presentation that we can answer afterwards. I do hope you enjoyed today's presentation. And with that, I will now hand you over to Siva to get us started.
Thanks, Rebecca. Before going to building clouds, today we can see that many organizations are moving or considering priority to move in cloud. Then it is obvious to the mind how to build cloud computing or a cloud storage. And another question comes into mind is building compute solutions. Who can help me? Either OpenStack or Kubernetes. What is the right size? Who can help on those things? When you talk about in terms of that, at Supermicro, we not only provide a performance-based optimized hardware, we also have end-to-end solutions. Either you talk about cloud virtualization based on Kubernetes or OpenStack or VMware or Docker, or it is a big data solutions, it is a Cloudera based or Auto Networks or a SAP or a analytics based SQL or whichever the operating system it is, can be underlying operating system can be Microsoft, Ubuntu or SUSE or Red Hat or CentOS, and also a software storage. It is going to be software defined storage, various solutions. Either it is going to be Ceph, Nexenta, or it is Hadoop or Lustre, whatever it is going to be. To that, every one data has to rest in the cloud at one or other solutions. So we always partner with the various partners to see optimum solutions to bring in. Today, we are talking about MinIO, the team with whom we worked very closely, and we are happy to bring that solution with this partnership. With that, I want to turn to our MinIO team to present the MinIO performance object storage. Matt?
Okay, thank you, Siva. Also, it was a pleasure to work with you guys too. So let's talk about high performance object storage in 30 minutes or less with Supermicro and MinIO. So what we're going to do today is talk about MinIO object storage. Then we'll talk about the Supermicro CloudDC hardware platform. And we'll talk about the testing that we did, where we benchmarked MinIO on the Supermicro CloudDC platform and the performance that we got, which was pretty remarkable. After that, we have a demonstration that shows you how to install MinIO, and we'll wrap up with a summary and some questions and answers. So let's start with what is MinIO. MinIO is a high performance Kubernetes native object store. We built MinIO from scratch to be cloud native. It runs under Kubernetes, and it also runs on bare metal. In fact, MinIO runs on just about anything. Their requirements are very low. It's a highly efficient binary. MinIO was conceived and built for large-scale cloud storage architectures and has distinguished itself to become the storage standard for hybrid cloud and multi-cloud architectures as well as edge. And again, that's all because it's such an efficient binary. From the very beginning, MinIO was designed to be cloud native, high performance, and simple. I think simplicity is something that is often overlooked. When you're building things at cloud scale, it is really important that all of your building blocks be as simple as they can possibly be, so that to increase operational efficiency. And performance is also critical, which we'll get to later. We'll spend quite a bit of time talking about why MinIO is high performance. And again, cloud native, Kubernetes native, total cloud DNA, pairs very well with the CloudDC hardware. MinIO is extremely popular, widely implemented as an S3 storage solution. It's funny because every time I make this slide, it's out of date by the time we give the webinar. We have over 800 million Docker polls now. There's someone running MinIO on every continent. I think we're at higher than 60% of the Fortune 500 run MinIO, and you can find MinIO on every cloud. So when we get to this slide, it's important to understand that at MinIO, we've defined the cutting edge of software-defined object storage. And these are just a few of the features that we offer. We're going to continue offering cutting edge features before anyone else does, and offering them at a high pace of innovation. Most importantly, I'd like to call out the best S3 compatibility available on the market outside of S3. Support for, let's talk about erasure coding and bit rot protection so you don't lose any information. Erasure code saves data and parity blocks and can be used to reconstruct data in case there's a hardware failure. And also something like active-active replication, which is an important aspect when developing hybrid cloud and multi-cloud capabilities. We do replication extremely quickly and efficiently across the multi-cloud. And now let's turn it back to the Supermicro team to discuss the CloudDC.
CloudDC. Now, if you can see on screen, I'll go from compact and then go clockwise on this. So the CloudDC product line, it is very compact. It's under 650 millimeter, which is roughly around 25.6 inches, and that's for the 2U. The 1U is even shorter than that at 23.5 inches. Now, in this size, we fully utilize everything. So the NVMe and the PCIe expansion slots are all using up the space given in this small form factor. Ultimate flexibility. So the system themselves support all hybrid drive bay. So whether you need NVMe, SAS, or SATA, we got that. There's internal storage options for dual M.2. And of course, in 2U, we can have expansion slots up to 6 of them. And if you prefer to put in a full-length card, that's also allowed. Application ready. So in the next slide, I'll show you what we mean by a balanced architecture. So the board itself, the motherboard, it's like a mirror of each sides. So all the resource is shared equally, and the loading is shared equally across both CPUs. And in terms of keeping it green, with platinum and titanium level power supply, will give the best efficiency for power. And for security, we offer all the secure features of Supermicro, such as root of trust. And for efficiency, the server is designed to be all toolless. So whether it be the drive trays or the the PCIe card brackets, everything is toolless. You can just pop it out and pop it in. It's very good for fast deployment and easy maintenance. So jumping onto the 1U compact server. Now, if you can see on screen, this is a dual processor server. It supports Intel Xeon 3rd generation of processor with 16 DIMM slots. So you could easily put up to 4 terabyte of memory in here. And the power supply default is 860 watt, but we do have an upgrade option to 1200 watt. And if you can see in the rear side, there are 4 expansion slots in 1U. The bottom 2 being OCP 3.0 cards. So you can put 2 of them for any networking needs, all the way from 1U to 100G. And then at the top, you'll see 2 half-length low-profile slots. So you can put storage cards and such in there. And the left and right side of these 2 CPUs are mirrors of each other. So like I said before, the resource sharing between the 2 is very good. And going back to the front, there are 10 drive bays. Now these are all hybrid slots, so you can either put SATA, SAS, or NVMe in there. So this is the 2U. So the 2U is a little bit more interesting in a sense that the rear side, if you can look at it, there's a lot of things going on here. So there are 6 slots, and we offer 2 configurations. So if you need more cards, you can either do more by 8 slots with a few by 16, or if you need more PCIe lanes, you can combine them and then turn into more by 16 slots. So either you can go with either 4 by 16 or 4 by 8 plus additional 2 by 16. And of course, the motherboard's the same, so the AIOM is still dual support. And if you can see at the top picture, the riser bracket, that is completely toolless. So you can just pop it out and pop it in. And at the front, there are 12 drive bays. So these are these support 2.5-inch drives as well in this 3.5-inch toolless tray. And they're all hybrid as well, NVMe, SAS, SATA. And as for the power supply, we offer 1200 watt as default with optional 1600 watt as upgrade. So this covers generally the 2 major product lines in CloudDC server. We still have 2 more in 1U. Next up, I'll hand it over back to MinIO team to talk about the benchmark data with CloudDC server and MinIO.
Sure. Thanks, Bala. All right. So we're going to talk about this benchmarking we did, but first let's talk for a few minutes about why MinIO is so fast. And the first point is that we are a single layer. We only do object storage. We're not doing file or block storage with a bunch of translations on top of it that slow down every API call. Looking at you, Seth. Okay. And we don't have a metadata database. We combine object storage and metadata storage into a single database, and we don't have to query multiple endpoints in order to serve or write an object. This means that every operation is single and atomic. This is more efficient than other vendors who have an external metadata database. Something that we spent a lot of time and effort on was building SIMD acceleration. We wrote core parts of MinIO in assembly language. In particular, this was for erasure coding. And we do this so we can run really fast on commodity hardware. Essentially, we use the registers in the chipset to do repeated calculations, and this improves CPU throughput and enables us to handle erasure coding basically in register and frees up the CPU so you get greater system performance. And again, we're written in Go. This is faster than some other solutions that are written in C. So we're in Go and assembly. We've done everything that we can to have MinIO be small, efficient, lightweight, and powerful. Turning to today's benchmark, we were really impressed with the performance that we saw from our small Supermicro CloudDC cluster. We had 4 nodes. We were running NVMe drives. In each of them, we had 100 gigabit per second Ethernet network connecting them. Once again, we found that network bandwidth was more of a bottleneck than anything else on the system. You can see we got reads that are on the order of 42, 43 gigabytes per second, writes in the order of 24 or 25 gigabytes per second. I think one thing that's worth calling out is that performance did not degrade significantly with the addition of encryption and TLS, which is important. So you might as well use encryption and TLS. Take the security when you can. There's very little trade-off. And another thing I wanted to point out too is that when we look at our sort of standard set of benchmarks that we have recorded, you can see that the 4-node Supermicro CloudDC performs very well when compared to the 8-node or a 32-node using NVMe. These were not on the same hardware, they were different. But if you extrapolate, you can see that this Supermicro hardware is pretty great. Also, for further reference, you can check out our blog and click on performance, and you'll see a full write-up of these benchmarks, or you can download the complete white paper, which explains every step that we took. Speaking of every step that we took, we ran the warp benchmark. This is something that we wrote at MinIO to test S3 performance. Basically, we do a lot of puts and gets on some S3 servers. You can download warp yourself and try it out. Warp is pretty cool because it can be automated and coordinated and scripted. You can use one host, you can use multiple hosts, although we do suggest using at least one client per S3 server that you're benchmarking in order to maximize load. And most importantly, you can configure warp to run a workload similar to your workload, using different size objects, changing the number of threads, turning TLS or encryption on or off. And that way you can do the most important thing that you can do when benchmarking, which is test using a realistic workload so you know it's applicable to what you're trying to do. And when we ran these tests, this was our configuration. We had 4 warp clients. We had a 100 gigabit Ethernet switch in between the clients and the MinIO cluster. And the cluster was 4 CloudDC servers, each with 2 CPU, 512 gigs of RAM, and 10 3.84 terabyte NVMe drives, all connected over 100 gigabit Ethernet. So we really didn't do anything that is that hard. I mean, this is something actually anyone could do. I mean, if I did it, actually, I didn't do it, Echo did it. And speaking of Echo doing things, I'd like to turn this over to Echo for a demo.
So hello, everybody. So today we're going to show a quick of setting up MinIO on 4 Supermicro servers using that same testbed Matt was talking about. So all that you need to set up MinIO is a number of disks presented in a JBOD fashion with XFS for that. And because this demo is running in bare metal, we're going to set up a systemd service to automatically start MinIO. So we see that we have all of our drives. When we have our drives, when we're setting up in FS tab, we're going to want to use either D or label. Under rare conditions, Linux can reorder the drives if you're not using these, and we don't want that to happen. So we'll go ahead and use the block ID command with the UIDs of the drives. And then we'll take a look at the FS tab that we've already set up. So here you can see that we've set up all the UIDs, and then you can also see we've set this no wait time directive to get a little bit better performance from the system. So once we've set that up, we can open up our firewall. By default, MinIO uses port 9000 to accept S3 API requests, and 9001 is the port that for our console graphical UI if you want to use that. So we can go and grab our MinIO binary now. The binary needs to have the permission and be put in the path that we set up in our systemd service. So we'll grab the binary. We'll make it executable. And then we'll put it, we'll check the permissions, and then we'll put it in the path that we're going to define in the systemd service file. So we do have sample configurations for systemd on our GitHub. So taking a look at these service files, we're going to have defined that same path and user that we talked about. And then we're also going to set the location of the configuration file. And we'll set this limit no file to make sure that we have enough open file handles, high performance workloads. After we've done this, we can move on to our configuration file. So in the configuration file, we're going to set this MinIO volumes environment variable. MinIO volumes defines the servers and the drives that will participate in the cluster. We have the MinIO root user and password. These are used to manage the MinIO cluster. They are not really the operating system. The MinIO Prometheus URL can be used to set up advanced metrics in the MinIO console. And you can set various options for MinIO using MinIO ops. Here we're just defining the API and console address ports. So once I've set these files up, I want to check all of the files across all of the systems. Because it's a distributed system, we need to make sure that everything is the same across the systems. It's also a good idea to check the MinIO binary. So here we've run the command, and we can see the SHA-SUMs are the same for the files on all the servers. So now that we have that, we're ready to go ahead and start the MinIO service. And once we've started the service, we just double check and make sure it's running. So from this output, we can see the active running, and that was it. That's all it took to set up a distributed MinIO cluster. So now that we have the cluster running, we're going to go ahead and grab this MC, which is our MinIO client for command line configuration and access to the cluster. When you have MC, you need to set up something called an alias. An alias is an arbitrary name that you use to address the cluster. In this demo, we're going to aliases so that you can see how the erasure code allows data to be accessible regardless of the endpoint you're using, but typically you would be using load balanced IP. So here we'll make a bucket. We're just denoting that it's from MC. for the demo, but it doesn't matter if you make it through MC or the console. It's no matter what. So we'll copy an object into that bucket. Now we'll set up the second alias. And see that even though we're hitting a different endpoint in the cluster, we still have access to that bucket and that object. So similarly, if I go to the console, first you can see that because we set up that Prometheus URL, I have advanced data about my cluster. I can see information about the cluster. I can see traffic that's gone in and out, and I can see resource consumption. So heading back over to the buckets, here's the bucket that we created from MC, and we can browse it and see that we still have the object that we uploaded. I can also create a bucket from the console, and just like MC, I can set advanced features like versioning or object locking, and I can do management of the bucket so that I can see things like setting a bucket policy for private or public access. I could set up replication or lifecycle management, and I could do things like setting up event notifications so that I could see, for example, if I got GET requests to a particular prefix. So going back to MC, I still see that same bucket that was made from the UI, and I can still copy an object to it, and I can still see that object in the console UI. So that was it, a very quick demo for setting up MinIO and interacting with it. And with that, I'd like to hand it back to the Supermicro team.
Thanks, Echo. Yeah, it is indeed that simple. After you rack and stack and network, under 30 minutes, you can deploy a production storage, object storage. That is very simple. One thing I want to highlight, I think Matt already mentioned about it. That is, during our testing, we have observed secure or non-secure object storage. We have seen overhead is very minimal or it is negligible overhead. So we can do a secured object storage solution in production in less than 30 minutes after rack and stack and networked systems. Having said that, at Supermicro, we always believe that each business is unique in its own respective path. So that's why we carry 250 plus form factors, and we can custom fit any solution for the customers what they need or requirements. At both the organizations at MinIO and Supermicro, we look forward for your business needs, and you can contact us anytime. We can be available to be happy to provide whatever solutions you are looking for, and we can customize to your needs. Thanks with that. I want to turn back and see, Rebecca, we have any questions?
Thank you. Thank you, Siva, Matt, Lon, Echo. And yes, I will now like to give our audience the opportunity to ask any questions. I see now that we do have a few, so I am going to start with this first one here. It is, how does MinIO protect my data? And what happens if a disk or node fails?
Oh, okay. I could take that one, Rebecca. All right. So MinIO protects data by using erasure coding. So essentially, you could think of erasure coding kind of like RAID in a way, except it's not limited to a single array. It works over multiple nodes and servers. And basically what this does is it takes objects and it breaks them into data and parity blocks. You can configure the level of redundancy that you require for for your environment at the maximum parity, which is n over 2. MinIO can actually provide uninterrupted read and write while losing up to half the drives in a system. And we also take this a little further. We do something called bit rot protection. Every time we read or write an object, we run a highway hash on it to determine whether it is the true form or if it's been corrupted. And if it has been corrupted, we fix it. So that's how we protect your data at rest.
Okay, thank you for that. Next question here. Are there any tools available to help me plan my MinIO deployment on Supermicro servers?
Oh, I could take this one too. Okay, so if you go to the MinIO website, there are plenty of tools available. We have a reference hardware page that lists the Supermicro configurations that we prefer. There'll be no surprise that it's the CloudDC. And you can also, on the MinIO website, we have an erasure code calculator. And what that does is it allows you to put in the number of servers you want, the number of drives, the capacity, and then change your erasure code settings so you can calculate the capacity, the usable capacity that you'll have. So you can really plan this all out before you actually purchase anything.
Thanks, Matt. I think from Supermicro side, we want to add a couple of things there. Yes, Supermicro always optimize the solutions on top of what MinIO provides a solution and the calculations. We also have Ansible scripts or a customized scripts, what is required for the customers to take forward on the deployment. We always look into solutions, how we can automate and deploy optimal way and how the business can benefit from these solutions. Obviously, MinIO has head started with their open source code, and at Supermicro also we have similar deployment tools that can help each and every customer. Back to you, Rebecca.
Perfect, thank you. We have one last question here. Is the community edition of MinIO the same as the paid versions?
Oh, I could take this one again. So yes, it is. The community edition has all of the functionality as the paid versions. The difference is that the paid version gives you an exemption to the AGPL v3 license. For those of you who are making MinIO available to applications across the network in production. And we also include in the standard and enterprise license our support offering, which is called Subnet. Actually, Echo, would you like to share with everyone a little bit about how awesome Subnet is?
Sure. So the subnet system was built to be kind of a marriage between traditional ticketing system and traditional real-time communication system. So something like Slack and Zendesk, but built just for customer access. We built it because nobody else had something that reduced friction the way that we wanted it to be. We want our customers to be able to reach out to us and have access very quickly and in real time. So with the enterprise plan, you have a 1 hour SLA, and that's direct to engineer contact. So you're not dealing with any kind of routing or L1 support engineers. You're dealing directly with the engineers that wrote the code. So the quality of responses and time to resolution on issues is incredible.
All right. Thank you, Echo. So again, there's the software is the same. What's different is the license and the support.
Yeah, to add that, I think we always recommend any POCs or anything. It's a community edition, but we always recommend in production deployments going for enterprise licensing. At the same time, we complement at Supermicro giving the support for the hardware and software at level 1 and take forward from there, so that combined both teams together, we bring a rich experienced experience to the customers.
Awesome. Thank you for that. Sia, Matt, Balan, and Echo. I think that ends our questions for the presentation. I just want to thank you to everyone for watching online. And we do hope that you got some key takeaways from this. And if you would like to know more, please follow the links in the attachments tab. And you can also visit us at www.supermicro.com. And also, we do value your feedback, so please make sure to leave us a star rating or comments in the feedbacks tab. And with that, I just want to say thank you again for joining us, and thank you to our presenters. I hope you all have a great day.
Thank you.
Okay. Thank you. You too.
Thank you.
Everyone.